Okay, ladies, so today we're going to do 10.3. Like I said, this lesson is on the quiz on Thursday, so make sure you're paying attention to this. And if you've got any questions, ask each other for help. Go talk to Mr. Silverman or your Algebra 1 teacher if you feel comfortable with that. They'd be glad to help. So here are the even answers that you had last night on the homework. And I'm going to give you about a minute to check these, and then I'll answer or go through a couple of the homework problems that I think you might have had a little trouble with, and then we'll start our notes. Okay, so the first problem that I'm going to do is 53, okay, with the coordinate plane and the circle. So I'm going to make a sketch of that. We had our center at M, we had a point L at 13, 0 on the graph. Here's my circle. J was at the point 5, 12, and K was at the point 12, 5. Okay, so I'm not going to do each one of these because they're all similar to each other. But part A wanted me to find the measurement of arc JL, which, remember, it's measurement, so that means pretty much what is the degree measure of the corresponding angle, in this case JML. If I know that angle, then I know my arc length. Well, the problem is I don't know that angle. If I were to draw in that angle, I don't know. You can't really guess very well either. So I'm going to show you what you can do though. I'm going to make a triangle using the origin in J. Okay? So I'm going to make this triangle, and I'm going to make it a right triangle. So I'm going to just drop this straight down. Okay? When I drop that straight down, this point is 5, 0. If that point is 5, 0, then the distance from M to that point is 5. Okay? This distance, the height of this triangle, is where my y is. In this case, 12. Okay? And I want to figure out, well, what is that angle? Well, now, using that information and the triangle that I just created, I can use trig. So, if I'm going to use trig and it's a right triangle, that means I can use SOHCAHTOA. I know the opposite and I know the adjacent, so it's going to be tangent of my angle equals opposite over adjacent. Well, I'm solving for the angle x, so I have to do the inverse. So tan inverse of 12 over 5 gives me about 67.38, but it wanted me to find each arc measure to the nearest tenth. So 67.4, because that's the angle, is 67.4, so that's also the measurement of my arc. Okay? B, finding the measurement of KL is the same thing. I'm going to make this triangle from K, drop it straight down, except now that distance is the X, 12, and the height Y. That's how you figure out the arc measure of KL. Part C wanted you to find the measurement of JK. To find the measurement of JK is really simple. I know JL, the whole thing, so I'm just going to subtract from JL KL, measurement of KL, and that'll give me that remaining piece. Okay? Now D, finding the length of JL. That's an arc. Whoops. Remember, that's when it's length over the circumference, 2 pi r, equals the degree measure over 360. So I'm trying to find the length, so I'm trying to find L. Well, my radius, I can look. L is on the point of my circle, is on my circle, and I can clearly see that it's a radius because it goes from M, and it's easy to count. That distance is 13. So my radius is 13, so my circumference is 26 pi, is equal to the degree measure of JL. Well, the degree measure is the same as the arc measure, 67.4 over 360. Cross multiply, solve for L. That's how you get D. Same thing for E. Okay, so that's 53. I'm also going to go over 66. Shouldn't have been too difficult, it's just area. So I'm going to go to a new page for that one. So for 66, it's the area if R equals 4. Okay, so I'm going to try to draw this the best I can. I had 4 circles right next to each other. Okay, it's kind of a crappy drawing, they're all supposed to be touching. And then the shaded area was in here. And I had radius being shown for all of these. Okay, well, my radius is 4. And if I look, all of the radii of the circle are the same. It's the same, they're congruent circles. So if the area of one circle, remember, is pi r squared, radius is 4, that's 16 pi. Okay? But I want to find the area of just the shaded region. Okay, my picture's not very good, but I can draw a box around this. Okay? Basically, my shaded area is the square minus all of these quarter pieces of a circle. But I know each quarter piece is the same because they're congruent circles. So, and since there's 4 quarter pieces, that's essentially the area of one circle. So I can find the area of the box, subtract the area of one circle, and that'll give me the area of my shaded region. This box minus the circle pieces will give me the shaded area. Well, the length of my box is, this is R, then this is R. So that's 8. And it's a square, so 8 by 8. So the area of the box is 64 minus the area of one circle, 16 pi. And it wanted the exact area, or at least the answer choices gave the exact area. So that's why it was A. Okay, if you had questions on anything else from the homework, feel free to go ask Mr. Silberman, and he will be glad to help. But for now, we're going to do the warm-up. I'll give you about a minute to try to complete this, and then we'll get started. Okay, so we know that BD is a diameter, AOD is 55. Find the angle of COB. Well, to find the angle of COB, I need to obviously know what X is. It's helpful to know that BD is my diameter, because that means that angle COB plus angle COD equals 180. So what I can do is take 4x plus 18 plus 10x minus 6 and equal that to 180 to figure out what x is. So I've got 14x plus 12 equals 180. So that's 14x equals 168. So that means x is 12. When I go plug in 10 times 12 minus 6, 120 minus 6 angle COB is 114 degrees. Alright, trying to find the measurement of arc MOL. Okay, well, it's a major arc, so I can subtract out this minor arc to figure out what the major arc is. And I'm going to subtract out from 360, because there's 360 degrees in the circle. So 360 minus 150, that is 210. So 210 is the arc measurement. Okay, another way you can try to figure that out is these make vertical angles, so this is 150, and these are also vertical angles. We're looking at the diameter. It's a linear pair of 30 here, so this has to be 30, so you can add up 30 plus 150 plus 30, and that will also get you 210. Alright, so 3, Diane runs around a circular track that has a radius of 55. After running 3/4 of the distance, how far has she run? Okay, this is like finding arc length. So the length, remember, over length over circumference, 2 pi r, equals x over 360, where x is my degrees. Well, she ran 3/4 of the track. So what is 3/4 of 360 degrees? 75%. You can think of it that way. Okay? Well, let's see. That should be 270. So 270 degrees. So the length over 2 pi r. R is 55, so that's 110 pi is equal to 270 over 360. Okay, you cross multiply. The exact answer should be 82.5 pi is your exact answer. Feet, or the rounded version would be 259.18 feet. Okay? Those are just the exact versus the rounded answers. You could have, instead of putting this there, you could have treated it as a percent and said L over 2 pi r equals 75 over 100, because that represents 3/4. You would have gotten the same exact answer. So if you did it like that, that's okay too. So moving on. Here we have another theorem. What it says, if you have in the same circle, or if this happens in congruent circles, okay, 2 minor arcs are congruent if their corresponding chords are congruent. So basically, if FG and HJ are congruent to each other, then the arcs that are made by them, arc FG and arc HJ, are congruent, and vice versa. If the arcs are congruent, then the chords that made them are congruent. Okay? Here's the proof for it. Don't even worry about that. Okay? We're not doing proofs. But if you're curious to know why it works, that's the proof. Alright. So we know that circle W has congruent chords RS and TB. If the measurement of RS is 85, find the measurement of TB. I just gave you the answer by writing it down. But the chords are congruent, so that means the arcs are congruent. So then the measurement of TV is 85 also. Alright, here we know we have congruent circles, and that arc WX is congruent to arc YZ. So I want to figure out what is the length of chord segment WX. So the arcs are congruent, therefore the chords are congruent. So to find WX, I need to know what X is. So I'll just set those equal to each other. 5x plus 6 is equal to 7x minus 2. And solve. So we have 8 equals to 2x. So x is 4. When I plug in to find WX, 7 times 4 minus 2, I get 26. Okay. So, a couple more theorems. If the diameter or the radius is perpendicular to a chord, then that means it cuts that chord in half, and it cuts the arc in half. It bisects it. If it's perpendicular. If it's not perpendicular, then that's not true. Okay? Or vice versa. If you know that the chord is cut in half and it's a perpendicular, then we know that BC is the radius, or AB is the diameter. Same thing. Okay? So these work the same. It's the if and only if type of situation, okay? Back and forth. So you know one, then the other one works. Okay, so we're going to solve for x here. I know HG is 10. So looking at this picture, it should tell you that DJ is a radius. Well, you should know that because it comes out of the center of J. But if HG is 10, we have perpendicular, so that means it's bisected. So 5 and 5. I want to figure out X. Well, what I can do is I know the radius of this circle is 10 because of JR. Well, I'm going to draw the radius here. 10. Now I can figure out X by doing the Pythagorean theorem. My hypotenuse is 10, so 10 squared equals x squared plus 5 squared. Give me an exact answer. 100 equals x squared plus 25. So 75 is equal to x squared. The exact answer should be 5 square root of 3. Okay, find RS. Well, again, perpendicular means that's cut in half. I know the radius is 13. But I want to redraw the radius so I can figure out what RS would be. But I can't just find RS in this problem first. I've got to find half of it, and then I'll multiply by 2. So I'm going to redraw my radius right here to make another right triangle and solve for x. 13 squared is equal to 5 squared plus x squared. Okay? If you'll notice, you get x to be 12. This is a Pythagorean triple, 5, 12, 13. Again, if you don't know it, that's okay, but it's going to be helpful so you can look at this picture and know, oh, 5 and 13, my missing side is 12. Makes things go faster. So then RS is not 12. That's only half of it. RS is 24. Okay. So the diameter is QS and it's 14 inches long. Chord RT is 10 inches long. Find out what VU is. Alright, so again, we have the diameter, and we have a chord, and we have a perpendicular sign. Tells me this chord is bisected. If RT is 10, then each part is 5. I want to find VU. Okay, this is just like the problems we were doing. I'm going to draw in a radius here to make a right triangle. I know the diameter is 14. I'm told that. Therefore, my radius is 7. So that's 7. I can figure out x by, again, Pythagorean theorem. My hypotenuse is 7, so 7 squared equals x squared plus 5 squared. Alright, 49 is equal to x squared plus 25. X squared is equal to 24. When I take the square root, it's not a nice number. So let's look at factors. We got 6 and 4. We have 2's, and we have 2 and 3. I have one pair, so that means I can pull out a 2 and leave the 2 times 3, 6. So x, which is VU, is 2 square root of 6. So, now we've got another theorem. In the same or congruent circles, 2 chords are congruent if they're the same distance from the center. Now, equidistant means that it's also perpendicular to the chord. Okay? If you don't know that it's perpendicular, then it's not going to work. Because it's like altitude. Remember, altitude is always perpendicular. Altitude and distance are the same. So, if I have 2 chords that are the same distance from the center, then that means the chords are the same. Which also means each little piece of the chord, each little half, is the same. Because it's a perpendicular bisector. It also works the same way. If you have 2 chords that are congruent in a circle, then they're the same distance away. Alright, so looking at this example, RT is 7. RT is only this little piece, and it's 7. And I can see by the markings on this picture that each of these chords are the same distance away. So that means that the whole chord is congruent to each other. Well, if RT is 7, RK is 14. We know RK is congruent to OC. So OC is also 14. Pretty straightforward. The thing about circles is they're not super difficult, but there are quite a few theorems to memorize. So I'm going to encourage you, again, to make note cards to do these theorems, or Quizlets, if that's what you prefer. So, moving on. I know XY is congruent to WZ. Okay. I know PR is 6x plus 13, and PS is x squared minus 3. Find the distance from P to XY. So basically that's asking me, what is PR? If these chords are the same, then by the theorem we just talked about, the distances to the chords are the same. So to find PR, well, I need to know x. And I can solve x by setting those equal to each other. So 6x plus 13 equals x squared minus 3. I've got an x squared, which means I'm going to have to factor. Move everything over so it's equal to 0. That gives me x squared minus 6x minus 16 when I simplify the 13 and the 3. Factors of this are a negative 8 and a positive 2. So x is equal to 8 and negative 2. Okay? Problem is, though, negative 2 doesn't work. I can plug in negative 2 here, and that'll give me 1. But if I plug in negative 2 here, well, that also gives me 1. So if that happens where both of your answers yield a positive, because remember I said you need to check it to make sure they both work. If both of your answers yield positive, then you have two options for your distance. In this case, the distance is either 1, or when I plug in 8, I do 6 times 8 plus 13, which gives me 48 plus 13. That's an 8, not a 3. 48 plus 13, which is 61. So you have either 1 or 61. Alright. If that happens on a test or quiz, you can put both answers down as long as they both make sense, because 1 can be a distance, 61 can be a distance, and I'll take either. But if you plug in a negative and it gives you a negative, and then you write that down as your answer, that doesn't make sense, so that's when you lose points. Okay? So the distance can be 1 or it could be 61. Okay? So suppose a chord is 16 inches long and is 6 inches from the center. Find the length of the radius. So draw a picture. Here's my circle. I have a chord that is 16 and it's 6 inches away. Now remember, when I'm talking about distance from the center, it's got to be perpendicular. So that means I can cut this in half, and it's 8 and 8. Because perpendicular from the center is a bisector. And I want to find the radius. So I'm going to draw in the radius there, so it's more clear. Okay. You can do the Pythagorean theorem, 8 squared plus 6 squared equals r squared. Or you can realize that this is a multiple of a 3, 4, 5 triangle. Because remember, that's a triple. If I multiply each by 2, I get 6, 8, and what's missing is 10. So the radius is 10. Again, beneficial to know those triples. Makes things move a little bit faster. You can do the Pythagorean theorem, you'll still get 10. So my radius is 10. Alright, last problem. Angle KMT is 30. The circumference is 24 pi inches. Find MT. Well, if the circumference is 24 pi, that's the only thing I really know, besides the fact that this is a 30, 60, 90 triangle, y'all's favorites. Okay? This can tell me what my radius is. 24, no, circumference equals 2 pi r. So 24 pi is equal to 2 pi r. I divide 2 pi. The pi's cancel out, and I'm left with r is equal to 12. Well, in this diagram, the only radius that's drawn is km. So that is 12. I'm going to pull this triangle out. Okay. And I want to know MT, which means I'll just put R here. I need to find MR, and it's going to be twice MR because it's bisecting that chord. This is 30, this is 60, 90, and this is 12. Remember, opposite of a 90 is 2x, opposite of the 30 is x, and opposite of the 60 is x square root of 3. So using this right here, what I know, 12 is equal to 2x, x is 6. So that means this is 6 here, and this is 6 square root of 3. I'm interested in what MR is because it's half of MT. So then MT is twice 6 square root of 3. MT. Therefore, MT is 12 square root of 3 inches. So you still got to know your 30, 60, 90 triangles. They continue to come back. They continue to build. So that's the end of this lesson. If you've got any questions, again, I encourage you to go see Mr. Silverman or any other math teacher. This lesson is on your quiz on Thursday. So make sure you know it. You got a couple minutes. You can start your homework and have a good day.